All right, so they were just talking about how carbon is carbon, right down to the last atom of carbon. But if you break it down, protons, neutrons, and electrons are all the same. Whether you're an atom of carbon or an atom of hydrogen, a proton's a proton. An electron's an electron, and a neutron's a neutron. It's just the number of them, and more specifically the number of the, what makes the element? The number of
Protons.
number of protons, right. So the number of protons is really important. Electrons can come and go, neutrons you can have more or less, but protons have to be equal to the atomic number or you're not that element anymore.
What is it? Well, atoms are made up of even tinier subatomic particles called protons, neutrons, and electrons. The atom's center, or nucleus, is a cluster of protons and neutrons. Protons have a positive electrical charge, and neutrons have no electrical charge. The atom's nucleus is held together by the strong force, which keeps the positively charged protons from repelling each other. The nucleus is surrounded by a cloud of electrons moving near the speed of light. The electrons have a negative charge that attracts them to the protons, and they live in shells representing different energy levels. On the periodic table, atoms are organized by their atomic number, which is really their number of protons, or electrons. You can also find the atomic mass here, as well as the element's symbol. I kind of think it's amazing that the difference of a few little protons, electrons, and neutrons can produce such a variety of elements with completely different properties. Different types of atoms can bond together to make molecules. Water is a molecule. It's 2 atoms of hydrogen and 1 atom of oxygen, or H2O for short. You would not believe how...
And that's how, even though we have about, close to 100 naturally occurring elements, we have millions of different types of matter because elements come together to make those different types. And that's, that's really important for who we are and being alive and nature itself. It would be a really boring place if there was only 100 different things out there. We sure wouldn't be here. So atoms are very small.
Small atoms are. It would take nearly 10 million atoms just to cross this dot. And the scale of the atom itself is even more ridiculous. If the nucleus was the size of an apple, the electrons would be 5 whole football fields away. Ow! That means all matter in the universe is mostly made up of empty space, which frankly blows my mind.
That's a good ending. You like it? Alright, that whole empty space thing is kind of cool. If you think about it, all the mass comes from that nucleus, and then the electrons, I often use the example, if you were to take a baseball and put it on the pitching mound at Fenway Park, the electrons would be way out in the outer bleachers or out, on Lansdowne Street. That's how far away they are from that nucleus. Well then what fills in all the other stuff? Nothing. So, theoretically, everything you see, and everything you are and everything in front of you is empty space. We should be able to put our hands through matter because it's basically a big hole with just a little stuff in it. But we can't. And I have this...
So wait, is that where those like microscopic holes come from and like everything?
Maybe. I don't quite know exactly what you're talking about, but theoretically, yeah, there's a lot of empty space filling all this matter up. So here's a fan. And if the nucleus... Okay, so here's the atom right here. And it's filled with empty space, right? And you can see through the fan. You can see my hands. And you can see that there's holes. And then every once in a while you got a blade that has matter in it, like an electron. Once you turn the fan on, though... Don't blow everything away. Now what do you see? Do you see individual fan blades? No. You see a big ring. And if I was to try to put my hand through this, my hand would keep hitting the blade. I wouldn't be able to put it through. While when it was off, I can take my hand and put it through one of those spaces in between the blades. And that's kind of how the atom is. Those electrons are whizzing around so fast, and they can be at any place at any time. That's all we know. They can be anywhere at any time in their certain energy level. That, we see things as solids. Or we see things not full holes. And that's hard for you guys to understand, but that's kind of how it is. It's kind of interesting. Questions? Parts of the atom. That's the basic stuff you really need to know for your MCAS in a month. We're going to take it a lot further than that, of course. You guys need your journals, please. And we're going to do two quick little examples, and then I'm going to have you do the rest of this. And I will pass this out. Actually, you know what? Don't. No journals. Let me give it to you. Yes. Don't go journals. Do it right here. All right, atoms and their parts. Who would like to read here a little bit? We'll get through this quickly. On your first paragraph.
Substances that contain only one kind of atom are called elements. Some familiar elements are oxygen, gold, silver, and helium. An atom is the smallest part of an element that can be broken down and still have characteristics of that element. All atoms have the same basic structure.
All right. Someone else, please. Go ahead, Jack.
With the exception of hydrogen, all atoms have three main parts. The parts of an atom are protons, electrons, and neutrons. A proton is positively charged and is located in the center or nucleus of the atom. All atoms of the same element have the same number of protons. The number of protons in the nucleus is called the atomic number and again is unique to each element. A different number of protons would mean you have a different element. Electrons are negatively charged and are located in shells or orbits spinning around the nucleus. The number of protons and electrons can be equal. This equality is so important so that the atom is neither positively nor negatively charged. It is said to be neutral. The third part of an atom is the neutron. Neutrons are neither positive nor negative and are located in the center of the nucleus of an atom, along with the protons. Protons and neutrons are the massive parts of an atom. Their combined masses are called the atomic mass of an element. Electrons are so light that we say they have essentially no mass.
Okay. So there you go. That's the basics of what we just went over. All right. So fill out the checklist here. I'll pop it up on the board. I don't have the checklist. So protons, neutrons, electrons. Do they have mass? What's the charge? Where are they found? And then figure out 1 through 5 for atom A and then atom B. And also, tell me what atom A is and tell me what atom B is.
Oh.
You should be able to figure that out now. You need your periodic table possibly.
Wait,
Go ahead.
What's different about a hydrogen atom?
You'll see it
Is that
in
what,
one of our examples.
Is that what atom A is?
How many protons does atom A have?
One.
One. What does it
Why
have?
why doesn't it have any neutrons?
There are 3 forms of hydrogen. The most common form doesn't have. It's the only. Hydrogen is really weird. We're going to find that hydrogen is an exception to a lot of things. We'll get into that a little bit more.
I think I hit mine in yesterday.
Do it again. Did you finish that?
That's why it's
For protons?
Well, I'll do it.
Go ahead. 1, electrons. 2, neutrons. Checklist for neutrons. Let's get this perfect.
There's a pen.
Use rinse.
So I just do protons?
Yep. You do protons. You do electrons. You do. I thought you were doing neutrons. You want to do neutrons?
I don't care.
Let's
Let's
go.
go.
Come on.
Yay.
Come on. Be on camera. You wanna
Pretty
do
sure it's
anime?
there. Merry Christmas. Thank you.
We're gonna need someone to do atom A and then atom B.
Mr. K, electrons, they say it essentially doesn't have mass, but it does. So
You are gonna go off the assumption it does not.
it does
Michigan.
not.
Michigan. Michigan.
Why 2? mass come from? Protons and how many neutrons are here? And if you look at your periodic table, the atomic mass for hydrogen is like 1.00001. How many protons does it have? What element has only one proton?
Wait, electrons.
Mr. K, when we write for a atomic number, do we write like the elements number or the atomic number we
If
get?
it asks for the atomic number, they would go to the periodic table
Oh.
and
Mr.
write the number in the periodic table. If it asks for a mass number, I would have to give you that.
Yeah,
Oh, okay.
the atomic mass, the book even says it's the average mass of all the isotopes in an element.
But the isotopes
That's correct.
are protons and
Yeah, protons and neutrons.
Oh, that's confusing definition. Two atoms with the same amount of protons.
I think
but
I
different
had a
amounts of
different one. If you
neutrons.
want to, I think I gave a little bit different one or added to that. If you just want to look on Anya's and copy her.
Mine?
Plain and simple, protons and neutrons. Who would like to come up and do atom A? Fill it out. Somebody different. Come on. Atom A and atom B.
Wait, electrons don't have mass?
Nope.
Oh.
Atom B. Somebody new? Please. Sean, go. What is the atomic number of atom A? 1, not 8.
Uh-oh.
Where'd you go, Brittany? Right at it.
Atom B. Protons. 1, 2, 3, 4.
That's the neutron. Number of neutrons.
It's the same.
That's neutrons.
Oh, neutrons is.
Count them
yeah,
up.
that's-
So don't erase. Count them up first.
It's 10. Electrons.
Do the mass of that. Do the atomic mass of that example.
That'd be 8 plus 10.
Yep. Cool. Alright. Who did protons? Is that Jack? Anya? Is that you? Protons?
I did electrons.
Who did protons? Okay, Jack, does it have a mass?
Yeah.
Yes. Is it positive, negative, or neutral?
Positive.
Positive. Is it inside the nucleus or outside the nucleus?
Inside.
Inside the nucleus. Electrons, Anya. Mass?
No.
No. Charge?
Negative.
Negative. Inside or outside?
Outside.
Outside the nucleus. Neutrons. Who did neutrons? You do neutrons? Gloria. Mass? Yes. Charge? Neutral. And inside the nucleus or outside? Inside. Great. Okay, atom A. They're not telling us what it is, but we can figure it out now. We'll get to that at the end. How many protons in atom A? 1. How many neutrons? 0. This is an exception. How many electrons? 1. Atomic mass of this? Total number of neutrons and protons is 1. 1 plus 0 is 1. What is the atomic number? And what element is it? Hydrogen, because it's got 1 proton. Sean, good job up here. Atom B, how many protons?
8,
8. 8 positive things. How many neutrons?
10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10 neutrons. How many electrons?
8.
8. What's the total mass of this atom, this example?
18.
It would be 18. 18 protons, 18 neutrons. And what is the atomic number of this element?
8.
What is this element?
Um, 8 is oxygen.
Oxygen.